Thank you very much. It's a pleasure and it's an honor to be here in this Congress, and thank you for the invitation, and thank you all for coming to this session. I want to start by congratulating the organizing committee for choosing this topic of sustainability of meat production, which we deeply believe it's key for the future of meat production. And I'm going to offer a short paper trying to discuss carbon footprint concepts that were already introduced earlier, and at the end I'll promise to do some linking to this playing in terms of some knowledge we have about sports. We'll see how that goes. I want to start by acknowledging my co-authors of this paper, Dr. Laura Astigarraga, Dr. Lucia Salvo, Dr. Lucia Gutierrez, and Master Gonzalo Becoña and Pablo Modernel, who are part of a team of researchers at the University of the Republic and also other institutions that have been working over the last 5 years on these issues of carbon footprint and sustainability of meat production. I hope your experience, for those of you who are not from Uruguay, you'll leave this Congress with many pictures and many images, and I'm sure you'll get a lot of images of livestock grazing systems, also nice images of beaches like Punta del Este, and if you have some time walking on the coastline here, you'll find the 5 fingers there by the coast, very close to this hotel. And before you get tired of grasslands and sand, I want to start with those 5 messages, and hopefully you'll be reminded by that monument of these 5 key messages. First, carbon footprint has various limitations as a sustainability indicator of the livestock system. It's an important indicator, but has various limitations. Second, carbon sequestration by pastures may change the size and design of carbon footprint. Third, local environmental impacts, such as soil erosion, pesticide toxicity, water eutrophication by nutrients, and biodiversity loss, should be also accounted for. Fourth, properly managed beef grazing systems can be more sustainable than confined feedlot systems, at least for the case in Uruguay. And thinking forward, improving grazing management can reduce carbon footprint as well as reducing other local environmental impacts, and that's the area I think we should develop in the future. So keep in mind those 5 messages. This paper is a synthesis of various papers that we've been working over the last 5 years, and the outline of this presentation, somehow the time is not working there, but I put mine, so I'll always be sure we'll make it on time. I'll go over five topics. First, climate change and livestock, which I'll go very fast on that because we were very lucky to have a great presentation by Walter Bethgen earlier, and so I'll just go through it very, very quickly. Then I'm going to give a brief description of Uruguay beef production systems, and basically our calculations of carbon footprint estimations on those systems in Uruguay. And then I'm going to move to other environmental dimensions, and finally discussing a broader holistic approach of sustainability of meat production. So Walter already described earlier in his presentation on climate change, we know the planet is getting warmer. The ice is melting, sea level is rising. There are several global indicators that are connected to the increase in carbon dioxide in the atmosphere and also in the oceans. And this is all explained by the greenhouse effect. Basically, in the atmosphere, there's gases that trap the heat, and therefore the climate is changing. So what's the reason of this? What are the sources of these greenhouse gas emissions? Well, mainly energy supply, transport, industry, and some bit of that is also agriculture and deforestation. And in summary, this global temperature is increasing and climate is changing. There's differences in rains, in winds, in storms, and the main cause is the increase in greenhouse gas emissions, mainly by human activity. There's a global scientific consensus about this, and there's also a global international policy agreement and several agreements in terms of governments to reduce greenhouse gas emissions that are already being trade barriers and will probably be increasing in the future, and also affecting consumer preferences on what products they choose. So this idea of carbon footprint is the total amount of greenhouse gases that are emitted both directly and indirectly from a product or a country or a person or something. And so this is a way of accounting for all these emissions. We have a graph there of the carbon footprint of different countries. Of course, United States, China are the largest contributors. Uruguay is just this little dot over here, and we have very little impact on the global carbon footprint. However, several reports, the first one was from FAO in 2006, started pointing towards the livestock sector as one of the responsibles for these emissions. And the first book, this was the Livestock Long Shadow, which basically estimated that the global livestock sector was responsible for 18% of all the greenhouse gas emissions. That turned into a lot of public media campaigns saying things like livestock is more polluting than transportation. Later on, there was clarification about this report. There was information that wasn't as accurate as they intended. Recently, last year, the FAO published a second report called Tackling Climate Change Through Livestock, and this, in these new calculations, livestock was estimated to be responsible for 14% of global greenhouse gas emissions. And I'm going to come back to this report at the end, because I want to question that we can really tackle climate change through livestock. We'll go back to that at the end. But the thing is that all these international reports, all this public awareness made very clear that for the meat industry, carbon footprint is a relevant issue to be concerned. In the case of Uruguay, which is a country that produces a lot of meat and we export a lot of that, and we have, as the minister said this morning, 4 cows per person and very little other things per person. So livestock is responsible for 66% of the emissions in Uruguay. And the reason livestock produces emissions are 3 main gases. There's methane, which is produced through enteric fermentation. There's manure that produces methane and nitrous oxide. There's the land use change, when we till the soil to grow crops, to feed the animals. There's some carbon dioxide that's emitted from the soil. There's also nitrous oxide emitted through the use of fertilizers, and also fossil fuel use like diesel and gasoline that also emits CO2. All those are the sources of greenhouse gas emissions by livestock. So how does this international context of climate change and the impact on livestock affected Uruguay? Well, in Uruguay, we received the concern from the Ministry of Agriculture, from the National Meat Institute, and some other places that say, okay, we need to calculate our carbon footprint, and that's what we did. So Uruguay, as you know, is an export agriculture country. Our exports used to be mainly beef. Now it's more diversified in terms of cereals, and soybeans, for instance, now are more than the value of soybeans is more than the value of beef. But a lot of our economy depends on these agricultural exports. Recently, there's been several, in the last decade, there's been great changes in terms of agriculture. Agriculture was expanded in area. It's also intensified. There's more crops in the rotations. There's continuous agriculture. There's more inputs. There's more soybeans in the rotation. And that has reduced the area in natural grasslands and some pastures. And there's also an increased use of grains as animal feeds, both as strategic for supplementation, but also structural sort of confined or feedlots. So in Uruguay, we have these three sources of feed for cattle. There's the natural grasslands, there's the sown pastures, usually mixes of legumes and grasses, temperate legumes and grasses, or the more grain-based feed systems that are always open air, but based on grain. And in terms of the production system, we have the cow-calf systems that produce breed the cow, breed the animal, that are mainly in natural grasslands and some area in sown pastures. Then there's the backgrounding from the 150 to 350 kilograms. That's again in natural grasslands or also in sown pastures. And then the finishing phase, which goes from 350 to roughly 500 kilos for the steer. That can also be done in natural grasslands, sown pastures, or grain-based systems, or combinations of these. So grasslands are the basis for our livestock industry, and the area in natural grasslands has been reduced, as I said before. There's some areas that it's less than 10%, there's other areas that's still 80, 90%, but on average it's around 55% in the country. So the objectives of our study were to quantify for the beef grazing systems in Uruguay, first, carbon footprint, but using various metrics, and I'm going to explain that right now, but also several other environmental variables like fossil energy consumption, soil erosion, nutrient balance, pesticide ecotoxicity, and impact on biodiversity. Our hypotheses were that the carbon footprint of different beef grazing systems will change when using different metrics for assessment. And this is important if we're going to play a lot of interest on the carbon footprint. But also the other hypothesis is that there are significant trade-offs among variables, other environmental variables with carbon footprint. So basically what we did is we look at 15 beef livestock systems, which were a combination of 3 cow-calf systems times 5 backgrounding finishing systems. The 3 cow-calf systems were what we defined the low performance, intermediate performance, or high performance, which came out of a study that we did a clustering out of 20 real farms. And then the 5 backgrounding finishing systems were defined by basically the extremes of this gradient of doing it all in natural grasslands, grasslands and seeded pastures, grasslands and grain-based, pastures, or pastures and grain-based. So these 3 cow-calf systems times the 5 backgrounding finishing systems generated a combination of 15 possible systems that in a way provided the range of systems we have in Uruguay. Don't think you can see it very well there, but those are the parameters of the systems. The cow-calf systems, for instance, we had the low performance had 61% of calf weaning rate and 0.4 stocking rate and 73 kilos of beef per hectare, and the high performance was 85% of weaning rate and 125 kilograms per hectare of beef production. The backgrounding systems in terms of grasslands or seeded pasture were 162 and 240 kilos of beef per hectare, and the fattening or finishing systems we had the 124, 260, and 443. The methodology we use, it's called the partial life cycle assessment, where basically we define a functional unit, which was the kilogram of live weight beef. We did an inventory of all the inputs needed, and for each input, the emissions that were calculated with different equations that are standard by models that are international models. And then when you have all the different emissions, you use characterization factors in order to add them up. And I'm going to give the example of that for carbon footprint. So in terms of the greenhouse gases, I already said that there's carbon dioxide, methane, and nitrous oxide. Each have different warming potential in the atmosphere. And the interesting thing of this study is that we look at actually two different ways of calculating that warming potential. On the one hand, there's the standard global warming potential, which attributes 25 times more power to methane than to CO2, and 298 to nitrous oxide. But there's also some recent publications that show that maybe we can do the calculation with a different metric, which is called the global temperature potential, the GTP, which assigns different numbers, and basically methane goes down from 25 to 4, and nitrous oxide goes down from 300 to 265. These are two different ways of estimating the potential that each molecule of gas has on heating the atmosphere. And they are all published by IPCC, and I really can't understand what's the logic behind it. It's chemical of the high level in the atmosphere, so I'm not an expert on that, but there's different ways of calculating them. So these are the results. When we look at the GWP metrics, this is what we have. The cow-calf systems were in the range of 28 kilograms of CO2 per kilo of beef. The intermediate around 20, and the high performance cow-calf systems were around 15. And then the backgrounding and finishing systems went from 15 to around 7 or 8. One of the things that you can see from here is that the main, with this metric, the gas that is more responsible for this is methane, the one that we should really focus on trying to reduce, the one that we should be doing research in terms of how to improve our systems is methane, which accounts for more than 60 or 70% of the emissions in all the systems. Now, when we use the GTP metrics that assign a lower value to the methane, first, we see that all the systems go down a lot, and the differences between the systems are very small. And the other thing is that now nitrous oxide is the key gas to manipulate, the key thing to worry about. And if we want to reduce emissions and the carbon footprint, we really need to focus on nitrous oxide. When we look at the 15 combinations, again, here we have in red the GWP and in blue the GTP. Again, what we have is this idea that when we look at GWP metrics, we can go from the worst system to the best system, reducing carbon footprint to almost half. But when we look at the GTP metrics, there's very little differences among the systems. So if we want to use carbon footprint as a metrics for evaluating which system we should propose, changing the different metric we're using, it's going to give us very different results. And that's one of the limitations of carbon footprint. The second thing is this issue of carbon sequestration. In the presentation earlier from Walter Betgen, he said we need, in order to reduce greenhouse gas emissions, we need to do mitigation, reduce emissions, but also we need to sequester carbon in order to get a better balance. Well, what we did in this paper, we calculated, we did simulations in terms of how much carbon a soil can fix, a grassland soil can fix, and it can go anywhere from 100 to 600 kilos of carbon per hectare per year. And when we apply that to the carbon footprint, we can get to reductions from 17 or 44% when we use the lower carbon sequestration, but we can go to 103 or 263 percent reduction when we go to the extreme of 600. That means that if our soils are able to fix that amount of carbon, the carbon footprint would actually not be an emission, it would be a net sink. That means we can reduce carbon footprint by carbon sequestration, and we can even change the sign of this. Of course, this is going to change with the type of pasture, species composition, grazing intensity, and other factors, and we really need to do our research and measure how much each soil is fixing in order to apply this. But it opens up also another question into the carbon footprint, that is that we're, in the standards, we're not allowed to use the carbon sequestration of the grasslands as a net sink. So that's something we should look to change in the future. Moving to, I hope I still have like 18 minutes, but if I have less, please let me know. Okay, fine. No, that's mine. That 18 is mine. I don't know who's keeping track of time, but anyway. If you get bored, just raise your hand and say something. So moving forward to other environmental variables. Here we, as I said, we also calculated not only carbon footprint, but also fossil energy use, soil erosion, nutrients like nitrogen and phosphorus balance, and pesticide risk for the different background finishing systems here. And as you can see in this graph, the systems that are using more grain and therefore do more agriculture are the ones that have lower carbon footprint, but at the same time higher impact on all the other variables, on fossil energy use, soil erosion, nutrient balance, and pesticide risk. Therefore, there is this trade-off between what we look as a global impact as carbon footprint and what we look at local impacts as these other ones. In our last paper, we also calculate what are all these trade-offs between all these variables, and I don't expect you to see this graph, but I'm going to focus on some of the trade-offs that I think are more relevant. When we look at the relationship between the fossil energy consumption per kilo of beef and the carbon footprint per kilo of beef, we get this trade-off. The higher the carbon footprint, the lower fossil energy consumption. That's sort of a paradox, because the cause of climate change is mainly fossil fuel emissions from fossil fuels. So if we are trying to reduce climate change by we're saying that the systems that have the higher carbon footprint are actually the ones that have the lower fossil energy. And so this is something we need to be careful when we account for this environmental impact. Another trade-off is again between carbon footprint and nitrogen balance. The systems that have the higher carbon footprint are the ones that have the lower nutrient imbalance. That is, those are the systems that are leaching less nitrogen to the water and are causing less eutrophication. So you see again this trade-off between one global impact and one local impact that's very important as water quality. And then also the grasslands biodiversity. Our grasslands are very rich in plant species. There's more than 1,000 species that we can find in a single area, but also a lot of mammals and birds and other species. And so we're very lucky as a country that we can actually farm that biodiversity and in a system that's pretty much natural, be able to produce food without the need of tilling the soil or changing the ecosystem. Well, again, when we look at the impact on biodiversity, and here impact in biodiversity was basically a proxy of how much natural grassland area the system was losing, we see again that the systems that have higher carbon footprint are the ones that with less impact on biodiversity. So all these trade-offs that we have, all these environmental impacts that we have can also be shown in this graph, this type of amoeba graph, perfect, where we see that the systems, for instance, the grassland-based systems are the ones that have higher emissions but lower of all the other impacts. And also, then comes okay, what do we do about this? We have all these variables, how do we add them up? Well, we propose one way of adding them up, which is basically doing the standardization of these figures and looking at and then adding them as normalized values, and we see that the grassland systems are the ones with lower environmental impact and the ones with feedlots are the higher environmental impact. But again, here there's a lot of assumptions that we need to discuss and that we need to develop a way of how to bring to the table to the policymakers and the stakeholders and say which of these variables are more important. So, summing up, carbon footprint is a relevant indicator and must be calculated, but carbon footprint has various limitations as a sustainability indicator of the livestock industry. There's different metrics that result in different recommendations, therefore you cannot know what to do. Carbon sequestration by pastures may change the size and sign of the carbon footprint and is usually not accounted for. And there are trade-offs between carbon footprint and local environmental impacts such as soil erosion, pesticide toxicity, water eutrophication, and biodiversity loss. So how do we move towards sustainability of meat production? Well, we need to consider all the dimensions, economic, ecological, social. We need to start valuing all these ecosystem services that our livestock systems are providing. We need to go past productivity and look at stability, efficiency, reliability, resilience, adaptability, all other dimensions that sustainability science is now looking into. And in the case of our grazing systems, the challenge ahead for sustainable intensification of livestock systems, we think, is grazing intensity management. That's a picture of an experiment where you have a high forage grazing intensity and a low grazing intensity. And the results of this experiment from SOCA and colleagues in Uruguay, and they are similar in Brazil too, we can double and triple the production of the beef productivity when we graze properly, when we allow the grass to grow higher and without a lot of reduction in stocking rates. So we think that by focusing on better management of the pastures, we can really improve productivity, reduce carbon footprint, and at the same time conserve biodiversity. So, finishing up with the key messages I started, remember those 5 fingers. Carbon footprint has various limitations as a sustainability indicator. Carbon sequestration may change the size and sign of carbon footprint. Local environmental impacts, the soil erosion, pesticide ecotoxicity, and others should be accounted for. Properly managed beef grazing systems can be more sustainable than feedlot systems, and improving grazing management can reduce carbon footprint as well as local environmental impacts. I said I wanted to come back to this idea of tackling climate change through livestock, and I wanted to go back to some things regarding sports. I don't think that we can really tackle climate change through livestock, and basically because I'm not familiar with this type of sports, but tackling is something that has to do with interfere with the forward progress of a player which is in possession of the ball. I don't think livestock is in possession of the ball, and therefore the reduction of climate change is going to be achieved by tackling livestock. Actually, if we can learn from our last soccer cup, and when I prepared this, I really hope that I had better examples to show, being from Uruguay, but this is the best I have. Rather than looking at tackles, that in this case Brazil had 5 and Germany had 1, we need to really focus on the goals, right? 1 versus 7. And so if we look to score sustainability goals, that's the way to go. High and stable productivity, high efficiency in water and inputs, lower carbon footprint, low soil erosion, low nutrient and pesticide leaching, low energy fossil energy use, high biodiversity conservation, high nutritional and health quality, high resilience to crisis and droughts. Those are the goals we need to achieve in order to get sustainability in meat production for the next generations. Thank you very much.
Thank you.